I have asked ChatGPT to calculate the following expression, in particular, integral from 0 to infinity of the summation over n from 1 to infinity of the exponential of minus n squared x divided by n squared dx. So it is quite complicated to see what I wanted to calculate from just this sentence. But let's see if ChatGPT interpreted my command in the proper way, in the correct way. Let's see. So this integral involves a double summation and integration. The integral that you have provided is the following. So integral from 0 to infinity over x. So we have dx. And then we have a series. So the integral is a series. Summation from 1 to infinity over n e to the minus n squared x over n squared. And let me tell you that this is the correct interpretation. So this is exactly what I wanted ChatGPT to calculate. And it is exactly coincident with this line here, with this sentence. Now, let's see if it can also calculate it properly, accurately. Let's see. So solving this directly is quite challenging because the double integration and summation, so the double summation and integration are intertwined. However, you can try to exchange the order of summation and integration, which might lead to a more manageable expression. And this is actually correct because this series here converges for every value of x between 0 and infinity. It is quite easy to see that because when you set, for example, x equal to 0, you have the summation over n from 1 to infinity of 1 over n squared, and we know that it converges to pi squared over 6, so that's a very famous expression. And when you set x to a different value, greater than 0, of course, it will still converge because this exponential factor will tend to let all those terms decay, so they will become smaller. And therefore, it is quite intuitive that it will converge for every value of x between 0 and infinity. So this is correct. We can swap the order between the series and the integral. And now it says, let's solve the integral. This integral here. This integral can be solved using standard techniques. You can let u equal to n squared x and then du equal to n squared dx, which is correct. The integral becomes 1 over n squared integral from 0 to infinity e to the minus u du. And it makes the calculation. So this calculation is correct, but we have to be careful because if you check, ChatGPT missed one factor of 1 over n squared because when you make the substitution, so dx becomes, since we have let u equal to n squared x, dx will become du over n squared. So instead of dx, we have du over n squared, which is here. But we also have to remind ourselves that we also have this factor of n squared. So this is actually a trivial mistake. So actually here we have n to the fourth, not n squared, if you think about it. And then we can evaluate, of course, e to the minus u. So the integral of that is minus e to the minus u. So the minus is here from 0 to infinity, and this evaluates to 1 over n squared. But actually, remember that we have also an extra factor of n squared, so we have 1 over n to the fourth. Now, substitute this result back into the summation, and you get this summation here. But we know that this is wrong because we have 1 over n to the fourth, not 1 over n squared. So ChatGPT here makes a mistake, and it assumes that the result is this one, and of course this is coincident with this pi squared over 6. And then I point out that ChatGPT is indeed wrong because I say, okay, you are wrong since you missed an extra factor of 1 over n squared while performing the integral. And ChatGPT says, okay, you are correct, and I appreciate your clarification. I made an oversight in the integration process. Let's go through it again. So the integral is this one. As before, we exchanged the order of summation and integration, and we get this. So with the integral, we have, so we let u equal to n squared x, then du equal to n squared dx, and the integral becomes this. But you can see that actually the result is the same, so it makes the same mistake twice. And then I point it out again, so I say, you're wrong again, the integral should become integral from u equal to 0 to u equal to infinity of 1 over n squared exp, so exp is the exponential, of minus u and then I have du over n squared. So in here, I point out that we have this extra factor of 1 over n squared, which when multiplied by this extra factor of n squared here should become 1 over n to the fourth. Now let's see if ChatGPT corrects this mistake. I apologize for the oversight. Let's correct the integration process. The integral is this, and okay, do the same substitution. Now multiplying by the original factor of 1 over n squared, so in this case it seems that the correction has been made correctly. So here you see this factor of 1 over n to the fourth, and what we get is the summation of 1 over n to the fourth from 1 to infinity. This is a well-known convergent series, and its sum is pi to the fourth over 90. So in this case, it seems that finally ChatGPT got to the correct result, but you can see that sometimes the mistakes are quite trivial because I mean ChatGPT correctly made all the other steps which were more complicated than the simple factor to take into consideration here, 1 over n squared. The extra factor was not taken into consideration at the beginning, but it was taken into consideration only after I made ChatGPT realize the mistake. And I wanted to show you this. I mean, ChatGPT is constantly improving day after day, actually, because at the very beginning, so a few months ago, I tried to let ChatGPT calculate some other expressions, and sometimes ChatGPT was not really able to interpret my, let's say, my sentence correctly. So it was not able to interpret, in this case, this integral correctly, and some other times, even the way that the equations are formatted was not really good because sometimes you just saw the lines of code without the actual equation. So you would see some not properly formatted expressions. But this is just an example. And hopefully in the future, ChatGPT will improve even more so that you will be able to calculate more complicated expressions like tensor manipulation or even problems in quantum field theory. At the moment, the results are not really good because I also tried to let ChatGPT manipulate, for example, the Riemann tensor in general relativity, but it's still improving day after day. So in the future, we might have more accurate calculations.